The local rugby league club needs to decide how many programs to order for its home games. Programs can be ordered in batches of 10,000, 20,000 or 30,000. These batches cost $1,000, $1,600 or $2,000 respectively. They will sell the programs at 20 cents each. The order for each match has to be placed a week in advance, and any program not sold on the day has no value. Sales of programs depend on the match attendance. For simplicity, assume that the program sales will be 10,000, 20,000 or 30,000. Find the MaxiMin, MaxiMax and MiniMax Regret strategies for program orders. Next Saturday, the team will be playing their arch rival. The general manager of the team estimates the probability of 30,000 sales equals 0.6, 20,000 equals 0.3, and 10,000 equals 0.1. Based on these estimates, what is the optimum EMV strategy under these conditions? Okay, the first step in answering this question is to work out what are our decision alternatives and what are our states of nature. So, in terms of our decision alternatives, we said that we could print 10,000 or we could print 20,000 or we could print 30,000. Now if we print 10,000, it was going to cost us $1,000. If we print 20,000, it was going to cost us $1,600, and if we print 30,000, it was going to cost us $2,000. Now in terms of attendance, what we said was that attendance could either be 10,000 or 20,000 or 30,000. Now, if 10,000 people turn up and they pay 20 cents per program, that will be $2,000, and it costs us $1,000 to make it, so we end up making a profit of $1,000. Similarly, if we have 10,000 people turning up, they'll pay $2,000 for the programs. But if we made 20,000, then we've got to pay $1,600 and throw away half of our programs. So our final profit will only be $400. If 10,000 people turn up and we made 30,000, well then it will be 2,000 minus $2,000, and we're not making any profit at all. On the other hand, if 20,000 people turn up and we've only made 10,000 programs, we can only sell 10,000 programs. So the result here will be the same as result here, and we will only get $1,000. On the other hand, if we printed 20,000, sell them at 20 cents each because we've got 20,000 people turning up, that gives us 4,000, and it costs us $1,600, so the profit is going to be $2,400. Now, if 20,000 people turn up and we made 30,000 programs, we've spent $2,000, we get the $4,000, we spend the $2,000, and so our profit is $2,000. Now, if 30,000 people turn up, but we've only made 10,000 programs, well, we only get to sell 10,000 programs. So once again, it's 2,000 minus 1,000 gives us a profit of $1,000. With 30,000 people turning up, when we've made 20,000 programs, we get the same case here. We get $4,000 for the 20,000 programs that we sell, and we had to pay $1,600 for them, so we get $2,400. Now, if 30,000 people turn up and we made 30,000 programs for them, at 20 cents each, that means we'll get $6,000 for all of the programs that we'll sell, and we spent $2,000 to make those programs, so we'll end up with a profit of $4,000. Now, we want to solve this using MaxiMin, MaxiMax, and MiniMax Regret. So step one is let's look at MaxiMin. In this case, we want to find out what's the minimum for each of the decision alternatives. So we're looking for the minimum out of 1,000, 1,000 and 1,000. I think you know that's 1,000. Then we want to find the minimum out of 400, 2,400 and 2,400. So that's going to be 400. Finally, we want the minimum out of 0, 2,000 and 4,000. So that will be 0. Now for MaxiMin, we want to take the maximum of these values, which is $1,000. So therefore, our final answer is make 10,000 programs. Next, we're going to look at MaxiMax. So in this case, we want to find the maximum for each alternative. So we're looking for the maximum. So for 10,000 programs, we're going to take the maximum of 1,000, 1,000 and 1,000. So this is simply 1,000. We want the maximum of 400, 2,400 and 2,400. So this is simply 2,400. And we want the maximum of 0, 2,000 and 4,000. So this is going to be 4,000. And then finally, we want the maximum of these maximums. So therefore, out of 1,000, 2,400 and 4,000, the maximum is going to be 4,000. So what we'll do is we will print 30,000. Next, we're going to solve this problem using MiniMax Regret. In order to solve this, we need to work out our opportunity loss table. So therefore, we'll start with 10,000 people turning up. We need to work out which is our best outcome in this case. We're comparing $1,000, $4,000 and $0. Obviously, the best one is $1,000 when 10,000 people turn up. So that gives us no regret. To calculate the regret for 20,000 people turning up, we get $400 instead of $1,000, so we have a regret of $600. Then, for 30,000 pamphlets being printed, well, we could have got $1,000, but we got $0, so our regret will be $1,000. Now, for 20,000 people, the best outcome is 20,000 programs being printed. So this one will have no regret. For 10,000 programs being printed, we only made 1,000 instead of 2,400, so we'll have a regret of 1,400. For the case of 30,000 printed, we'll only get $2,000 instead of $2,400, so we'll have a regret of 400. Now when we look at 30,000 people turning up, our best outcome is we get $4,000 if we print 30,000 programs, so that gives us 0 regret. So if we only printed 10,000 programs, our regret would be 4,000 minus 1,000, which gives us 3,000 worth of regret. If we had have printed 20,000 programs, we would have a regret of 4,000 minus 2,400, which gives us a regret of 1,600. Now what we need to do is to minimize the maximum of the regrets. So we need to work out what are the maximums. So what are the maximums for each case? We've got 0, 1400, 3000. The maximum is 3000. We've got 600, 0 and 1600. The maximum is 1600. We've got 1000, 400 and 0. The maximum is 1000. Now what we need to do is find the minimum of these maximas. And the minimum out of 3000, 1600 and 1000 is 1000. So therefore, we will print 30,000. In order to determine the EMV, we need to know the probabilities of the different states of nature. In the question, we were told the probability of 30,000 people turning up was 0.6 because this is a grudge match with our biggest rival. The probability of 20,000 people turning up was 0.3, and the probability of only 10,000 people turning up was only 0.1. Perhaps that's the chance that there's a big thunderstorm and no one wants to turn up. So now we need to calculate the EMV of 10,000 programs printed. So it's going to be 1,000 times 0.1 plus 1,000 times 0.3 plus 1,000 times 0.6, which I think is pretty obviously going to be $1,000. And I'm simply saying that because 1,000, 1,000 and 1,000 are all the same. 0.1, 0.3 and 0.6 by definition add up to 1. Gets a bit more complicated for 20,000 programs printed. We're going to have 400 times 0.1 plus 2,400 times 0.3 plus 2,400 times 0.6. So this will give us $2,200. And now for printing 30,000 programs, we're going to have 0 times 0.1 plus 2,000 times 0.3 plus 2,000 times 0.3 plus 4,000 times 0.6. In this case, we get $3,000. Now, for the expected monetary value, we'll take the largest one of these, which is $3,000. So therefore, our choice is to print 30,000 pamphlets.